And that's the stuff you're supposed to know, but you might not remember it. But today I have a headache, so try to stay with me. If I'm unconscious, pass out, call emergency. No.
We're all CPR certified. Are we really? They gave us those ones. Yeah, but those are not.
All right.
We know what the process of CPR is, correct?
What is the? Okay, so yes. So all right, so did I stream or no? I already forgot what I did. Oh, I did. Wait, why isn't this in the old thing?
I'm already on live stream is crazy. I don't try to do it. Now it started. No, I'm not.
All right. Yesterday we talked about sequence, and so today we're gonna talk about more sequence. So what kind of sequence we're gonna get to? So let's see what we have. We started and here. So get your notes out. So we're just gonna talk about what we talked about yesterday. So we can sequence. We can have the node as an, just use a brace. So the brace means it's a set of sequence. So it's gonna be A1, A2, A3, A4, dot 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 dot. That n be positive integer, which is natural number. Positive integer. We already did this, right? But I'm just going over this part. We're gonna denote as an a brace infinity and n equal to k. So usually your lower bound, and if the lower bound is not present, then it's gonna be 1. And infinity usually is on the top. Yeah.
So if n is equal to k, it's equal to 1.
Huh?
If n is equal to k, it's equal to 1.
N equal to 1. They would say n equal to 1 or not say anything. If not say anything, n is equal to 1, because sequence you have to start with the first term, so n has to be equal to 1. Now, can they start a second term? Of course, they can start a second term. Okay, so yesterday we talked about this sequence to the n plus 1, 2 to the n over n plus 1. And we says this brace has, we can do n equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5. And we can have the situation. And pretty much just plug in the number. I think we did yesterday, right? -4/3 to yada yada, -16/5, and 16/3. Now, here's the thing. It's very hard to look at this and tell me a general formula. So I'm going to give you an easier one for you to try. So here's an easier one. So we had to come up with this, okay? But this one I'm going to be a little bit different. I'm going to give you a to the second term. You start a second term, right? So the low bound has to change, right? a to the third term, a to the fourth term, a to the fifth term, and a to the sixth term. And we're gonna start with the 0, -1, square root 2, negative square root 3, and 2. I want you to come up with a sequence that fulfill those conditions. That where a2 is 0, a3 is -1, a4 is 2, and a5 is negative square root 3, and a6 2. So you need to come up with the equation like that. See if you guys can come up with it. Do you see the sequence that make this term? How many guys have come up already? Only one? I need one more. I need a few more. So it's like those. A lot of people will actually enjoy sequence, and a lot of people actually hate it. Hopefully you are gonna enjoy it rather than hate it. Is it one of those things that some people have it right away, some people don't? Because it doesn't have a systematic way to get to that. Huh? What'd you say? Yeah, unfortunately, I hate to use that word because writing's gonna be like it's intuitive. Did you get it? No.
Yeah, like a chunk of it.
Chunk of it.
And it's alternating. It's -1. Yeah.
Well, we know that. Everybody knows that.
-1 to 10. Let's start with -6.
Okay, how many of you guys got it? Besides Bennett. Joshua got it too? Good job. I mean, you can plug in, you literally see those terms happening. Claire, Misha? You guys got it? Tag team? You guys are supposed to be a good team? Okay. If you didn't get it, I'll help you because 2 is also can see a square root 4. And you do see 4, 3, 2, 1. So it has to be some type of radical. Radical of something. Well, you know the first term has to be 0. So it has to be m minus 2. Because if you plug in 2, it has to give you 0. So that would give you 0, 1, 2, 3, 2. 1, square root 2, square root 3, and 2. That would give me that. But then you're going to say -1 is alternating. First term is positive. So is what? N. So if n is 2, then if 2 is positive. So that's correct. So this is going to be the boundary of n equal to 2. And this is going to be all the way to 6 if it stops at 6. Does that make sense? You want to try this again? Let's do it. Okay, let's try this one. This one's fairly easy. 2. 3 over root 2. So there's a sequence. And I'm going to use brace. 4 over root 3. 5 over 2. Dot, 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 dot. This is an easy one.
What number this is? Is it A1? Is A1? Yeah, did it start with A1?
Yeah, do start with this is A1. Yeah.
This 2.
Yeah, I didn't write down n equal to something, so it has to start with this one.
squares.
It's a brace. I don't know how to do it.
I don't know.
I just do squiggle.
Wait,
Some people can do it really well. It's like
oh, it's a thing that goes like from
I can't do it. I can't do it. Whatever. Squiggle line's better. I give up. I'm done. If you're done, raise your hand. 1, 2, 3. Ooh, McKenna. Nice. Armin. Alright, okay. Okay. So usually break up the two parts is easier. Break up numerator and denominator if you see a fractions. Then you can see the pattern of each numerator, each denominator, see how it's gonna go. Yes. Fiona, you come up with it? What'd you get?
What's the subscript
M plus 1. Okay, it's the top. That's the top.
That's like so like n to the n plus because you only have n plus 1 over yeah n plus 1 over square root of n.
M plus 1. Square root of n. Good. So this is an equal to that. Yes. Is this okay? Now let's give you a little bit challenging. You ready? No? Okay, -1. Squiggle line. 1/2. -1/6. I think they probably have a different name inside called a squiggle line. But I'm still gonna call it squiggle line. Let's see this one. It requires different notation on this one. You want me to tell you that? You want me to give you a hint?
No one's like
No, I don't want to answer.
I'll give you a hint. I won't do the hint. Surprise! That's the hint. It's gonna confuse you more. Surprise!
Oh wait. Oh, no way to help you. That didn't help.
oh no
Oh, still in two.
Shut up.
oh okay but how do I write this yeah how do I write this out how do I write that out
Surprise!
bro I don't know how to write this times yeah the bottom 3 times oh I know yeah
That's so dumb.
in time
I give it for every other one.
if it's trying to find like you're trying to give 6 times 4 is 24 times 5 is 1 plus 25 I don't know smart the top is 1 right yeah -1 to the
It works for every.
but how do I write the bottom
Yeah.
why is it a plus
I don't know. You haven't told me.
I did teach it last year. It's certain notation. Surprise!
Yeah.
okay
Yeah, see? You got
everything in one but n to the 4. So I basically got it. Surprise! That's what it is.
I know my hand is great.
You were hit once, but like I was never getting that. No one was ever getting that.
Yeah, no, I try to confuse you more.
Wait, okay, so that is a 5. Read. E times.
E, how'd you get?
I said 3. Yeah. E. I don't know how to write it out.
All right, so for those you guys don't know my hand, surprise.
Like surprise.
But it didn't work for everyone.
How to spell surprise? Okay, so those of you guys don't know, 5 factorial is a 5 times 4 times 3 times 2 times 1. See, it's called factorial. It's not called exclamation mark. Factorial. Factorial. So 4 factorial is equal to 4 times 3 times 2 times 1. 3 factorial is equal to 3 times 2 times 1. 2 factorial is 2 times 1. 1 factorial is 1. So here's my question, guys. Here's my question. What is 0 factorial? What's 0 factorial?
With my phone.
0 times negative infinity.
What is 0 factorial? It is 1.
Negative 1/16?
Because, shh. And there's a reason why I write out everything, right? Brandon, put your phone away. Divided by 2. Divided by 5. Divided by 5. Divided by 4, sorry. Divided by 3. Divided by 2. And divided by 1. So therefore, 0 factorial is 1. Okay, so you follow the pattern. You divide each time. So you go to 1. So 0 factorial is not 0. 0 factorial is 1. Okay, so not only that, I want to go over some algebra 2 skill. So how would I simplify? Now, we're going to come back to this, right? How would I simplify m plus 2 factorial over n factorial? So how do I simplify m plus 2 factorial over n factorial? This, yeah, that's what. So when I grew up, my algebra 2 class, we actually had to deal with factorials. 30 years ago. No. I suck at China in math. I failed my math class. 15. My transcript of math class is 12%.
Distribute a factorial.
12%.
You distribute factorials.
So it was an F. So when I come to here, they move in to a like intermediate math class. So that class basically teach you how to do 3 plus 4, 6 plus 8. No, I was a genius. That was my best time in high school. I was a genius in that class. They think I'm God over there. Seriously, they think I'm God. Like, how do you finish your test in like 2 minutes? Oh.
I know by time
Yes.
Would it just be?
I'm gonna pay you back in Girl Scouts.
Would it just be n minus 1 times n minus 2?
You are absolutely right.
How are you so smart?
Yeah, no. How is he so smart? So if you can change this, right? N plus 2, right? That's the first term, times by n plus 1 times by n factorial. I'm gonna stop there. Of course, I can keep on writing n and m minus 1, m minus 2, m minus 3. But since I see a m factorial on the bottom, can I just simplify this? And it's gonna be n squared plus 3n plus 2.
Because you're following.
Okay, so
Yeah, where do you get the plus one?
huh?
Where do you get the n plus one?
Because you know how is it multiply the next number? So n plus 2, what's the next number? N plus 1, right? Yeah, so it should be keep on going, but I'm gonna stop here because I see an n factorial on bottom. I can simplify.
What? And how does it turn into n plus 2 times n plus 1?
Because Brandon, the 100. Because when you do 100 factorial, you're dividing everything 100 times 99 times 9. So you have to add 2 more to it. And plus 4. So it's like if you do 98 factorial times n plus 2, you get 99, and then 100 I have right here divided by this 98.
Okay. Shh. Everybody understand so far? Not really? What? Brendan's is kind of dumb. It's okay.
I don't feel that. Not intuitive at all. I don't. Yeah, I agree with Brandon here. I don't think we ever learned.
I didn't even know what
Okay, so I'll give you one. I'll give you one. N plus 2 over m minus 1 factorial. Hold on a second. This is a factorial here. Ethan, of course. Ethan, what is Ethan doing? Ethan, why are you skipping my class, sir?
Yo, that woman opened with, "Do not go into college." I'm like, okay. Why did you say?
Why are you going to college?
I'm looking at my paper, bro. I'm just making more educated gamers out here.
Okay, yeah. Hey, stop yapping. Get the paper out.
Wait, what is that? Where did that?
What
What is the n squared?
N
Hold on,
minus
Archie,
one.
no. Come on, I do negative. N minus two.
Oh, so n minus.
The N would be negative. Negative.
Wait, what if the n squared plus 3 plus 2?
It's multiplied by n plus 1 times n plus 1. It's just distributing. That's not intuitive. That's basic. Okay, what'd you guys get? You should not take it as long. You don't know how to simplify factorial?
Oh my gosh.
Can you go backwards?
They
and
go
back
up,
down?
you multiply by the next.
Then mine's technical. Oh, no.
Okay, how many of you guys are done? No one?
Wait.
Okay, so come on, it's not that hard. So this is m plus 2. So I'm gonna write down what's the next term. Good job. What's the next term? N. And then what's the next term? M minus 1. But I'm gonna stop right here. What? Hello?
I did that. Bro, where's
Oh, yeah. You are smart. Okay, so Yeah, you can stop here because you have something that you can cancel. You stop there because you always choose a bigger number, right? And you just simplify it down until the small number will cancel out. That's pretty much it. Yes.
So there's a factorial.
So you thought when you
Wait,
What?
why does that end at n minus 1?
It doesn't. You can keep going.
Keep going. So it goes n minus 2, n minus 3, n minus 4.
Yeah, but that could be rewrite as n minus 1 factorial.
Okay.
Okay, so yes, Aiden.
Oh, so you just keep going until you cancel it out. And that's what
Yeah.
Yeah. So you have the same factorial you can cancel. Yes.
Negative for like finite factorial.
I don't know. You can invent that part of math because I didn't know. All right. So so on the bottom is 1. So 1, 2, 3. So 1, 2, 3, 4, 5. So it's gonna be n factorial. Is that okay?
Oh, and
On the top, it's gonna be negative 1 to the n or n plus 1 to the n. All right. Is that okay?
Yeah.
Okay, that's it. So it's not that hard. It's just different. Okay. Let's talk about another type of sequence. So
What is this called again?
this is called sequence. But this is a review for algebra 2. This is algebra 2.
Neighbors did not happen
All right, so I have a headache, please. Okay, so A1 is equal to 2. A2 is equal to 4. Now, I'm going to tell you that this is some type of recursive sequence. And recursive sequence is based on your prior term. Okay, your sequence is based on a prior term. So I will give you instruction. So this is a recursive sequence. And so I told you the first term is 2, second term is 4. But I also give you a pattern. And this is the instruction. an plus 1 equal to 2an minus a to the n minus 1. And you're like, wait, what is this? So this is actually told you the directions. Now what I'm going to do is, hey, I'm going to figure out your next term. And you're going to realize that if I plug in, if I says, we already have A1, we already have A2, right? What do we want? We want A3, right? Well, A3 is equal to A to the 2 plus 1. What'd you say? It's equal to 2A to the 2 minus A to the 2 minus 1. I basically replace the n with 2, so I can get 3. And then I can say, oh yeah, that's going to be 2 times A2, which is 4, minus A1, which is 2, which is the next term is going to be 6. So A3 is equal to 6. Can you figure out what A4 is? Can you figure out A4? A4 is what? So this is called recursive sequence. Yes.
It's called recursive just because we're using the previous.
Yeah, we use there was always an instruction, and that instruction is based on the prior term. Yes.
Are we going to learn how to because I remember on the math contest there was one where you plugged in infinity.
Yeah, that's later. But we usually don't have to do that with recursive. Yes.
Give us a different formula.
Yeah, they can give you. They can say it's a to the n plus 1 is 2an or 3an, right? They're all different, right? Because it depends on instructions. Is that okay? Does that make sense? So so A4 is equal to A3 plus 1 equal to 2. A to the 3 minus A to the 3 minus 1. So be 2 times, well, A3, we already have it because this is A3, right? 6 minus A to the 2, which is A to the 2 is what? 4. So be 12 minus 4 is equal to 8. So this is actually an instruction for what? Even number, right? You can make sure again. You can say A5 is equal to A to the 4 plus 1. 2 times A4 minus A to the 3. So 2 times 8 minus A3, what is A3? 6. So be 10. So it's actually, it's 2, 6, 8, 10 is the even number. So this is called recursive sequence. They will give you a special instruction. You just follow the instruction with the term. And that's called recursive. Okay, we might have to deal with that later, but not too much. You're not gonna see on AP exam, but yeah, you're gonna Okay, is that okay? All right. So what we're gonna do is we're gonna go into the next thing, which is we're gonna talk about some property. So we're gonna skim through all the properties in a second. This recursive is also in Algebra 2, actually. Huh? Y'all just weak. Okay. If you're all like me, you're taking Algebra 2. All right. So. Well, now it's Calc BC. How about that? Okay. So first, I have a limit. I'm gonna talk about properties. So PROPERTIES. Thank you. And approach infinity. I can tell who went to spelling bee. CAN. You never? I can see you in spelling bee.
Wait, Bernice, you never knew how you totally give off like spelling bee vibes.
Yeah. She does give it like a spelling bee vibes.
Like can? Yeah, do you think I ever did a spelling bee?
No.
Yeah.
No offense. I don't think ever white person went to spelling bee before.
Hey, wait, where's Nelly? Nelly and Clara both really good at spelling. Verda Clay. Remember that? Oh my god! I'm still mad about my first grade. Nelly's
You're salty about certain words?
I got 6th place, dude. I know.
That was kind of weak.
Do you remember Mr. Wallace's spelling bees?
sh-
Yeah, I was just.
Okay, so all right, hey, let's focus on the board. Thank you. So you can have two sequences. So right now we talk about limits. Let me talk about limits first. Limits is a sequence. Sequence has a limits. Okay.
Yeah, that is true. That is the rule. Yeah.
Okay, so let me talk about this, please. If len m approach infinity of a to the n, so you have a two result. First result is very easy. If limit exists, then we call it converge. It's kind of like improper integral, because when proper integral come out with a finite number, then we know it's converged into that value. Now, second situation, if limits does not exist, then we're gonna call that diverge. Or divergent. Okay, so that's two things. So you can equal to a value, then that's converge. If it's equal to infinity or other situation, it would be diverge. But we haven't addressed other situation yet. So we're going to talk about that. So you can have two sequence. So one sequence is a to the n, second sequence is b to the n. That's just going to be limit n approach infinity of a to the n plus limit n approach infinity of b to the n. The third property, limits as n approach infinity of a to the n times b to the n, is really like distributed property. So n infinity of a to the n times limits as n approach infinity of b to the n. The fourth property is limits as n approach infinity of a to the n over b to the n. You guessed it, limit approach infinity a n over limits n approach infinity of bn. Limits as n approach infinity a to the n p equal to n approach infinity of a to the n to the p.
Connor was telling me calculus is fun today.
It is fun. But again, Connor's kind of.
Bro, he was laughing at me.
This is wait, why do you think like
That's it. What is that?
Okay, so this property is very standard. It's kind of like distribution, and it's always like this. But we're gonna talk about a few different situations. Are they converge? Are they diverge? The first sequence is actually pretty interesting. It was a -1 to the n, and that's the sequence. No. So, well, if Ben is asking, then I'm gonna say no. Other people asking, I might say
somebody asked might be
I'm still writing stuff down.
because when he asks, I just shut up in it. Shut up in it.
I tell my mom, but she's just laughing.
Right?
Then I was gonna tap
I
on you.
told my mom that I don't think I'm dyslexic, and she laughed at
What?
I was like, I don't think I'm dyslexic. Oh my god.
What the hell is going on, man? All right, so -1 to the n. So this sequence look like this: -1, +1, -1, +1. Right? So is this sequence exist? No, it doesn't. Remember the oscillation? It's oscillating between 1 and -1. Yeah, so we call this divergent.
Wait, why does it exist?
Because we don't know if it end up to be +1 or -1. We not converge into something.
I thought you said it wasn't.
No, it just we don't know what happened. Is that -1 or +1? So that's the first situation. So hopefully you understand that.
Take a shot if you do.
What? All right. The second situation I'm going to talk about is what if I have a sequence look like this? Is this converge or this diverge?
Figures to infinity.
Mm-hmm. Well, why is converge 2?
Because I just remember to divide by n.
Yeah, you do divide it by highest degree on denominator, yes. So imagine this is limit x approach to infinity of 2x over x plus 1. I can divide it by the highest degree of denominator, so I divide it by x on all of them. So it be limits x approach infinity of 2 over 1 plus 1 over x. This will end up be equal to 0, and this will end up be 2. So this is a converge.
Mr. Yeh,
Mm-hmm.
how would you do that in terms of number 4?
What do you mean number 4?
Because it says number 4, limit n approaches infinity of a to the n over b to the n. Is equal to that. So how would you do it in terms
No, we are doing this. This is a whole sequence. We're not based on two sequences. So if the two sequences, then that's okay. But this is only one sequence.
But how do we know if it's two sequences or one sequence? Because
This is the one. This is just a to the n. It's not a to the n over b to the n. Okay, 3. This one's interesting. I want you to think about this one. Okay, 2 plus an equal to 2 plus negative 1 to the n over n. Is this converge or this diverge? Is it converge or diverge? Why do you think it's diverge? It is oscillating, but it's not diverge. You tell me.
no, that's a fair question.
Yeah, you only have 50-50, but you gotta give me a reason. Converge, diverge, that's not how the way it works. You have to show me why they are converge and why they are diverge.
Oh yeah, that makes sense. Negative plus
So what if you have x approach infinity of 2 plus negative 1 to the x over x, right? We still can divide it by x because that doesn't change the property. It's 2 over x plus negative 1 to the x over x over 1, right? So what happened when approaching infinity on this one? 0. What happened to this one's oscillating between 1 and negative 1. You're right about oscillation. But if it's 1 over 1,000 and negative 1 over 1,000, and the 1 over 10,000 versus 1 over negative 10,000, what are they both equal to? They go into 0 still. So this is 0, this is 0, this is 0. So this is converge into 0. This is converge, not converge into 0. What's the difference? Are we okay here?
Dude, if that was a 2, you'd have to do it.
Okay, the next situation I want to give it to you is, what if I have a sequence look like ln of n over n? ln of n over n. Do you think this converge or this diverge, and why? Right, that's correct. It's the limit n approach infinity of ln of n over n. Also, a lot of time people actually see which one's going to go to infinity faster. So n is going to go to infinity faster than ln of n. And that's equal to, this is equal to 0. If you do L'Hopital rule, it's 1 over n over 1. So that's equal to 0. We still need to talk about 50 case. Remind me to talk about 50 case tomorrow.
About what?
Remind me we're going to talk about 50 case.
Oh my god, on your pen.
You say Ayomaya? That's so Chinese. That's so Chinese. Ayaya. Apple says that? So Amen, see you tomorrow. Amen. We want to win another trophy.
I'm going over my test from last time because I got this question right, but it was kind of guesswork because I just realized that none of the answers could be right because it was going to infinity, but it was like, I don't know, none of the answer choices are right. So, I don't know. But it's cool we're learning about it
Bye. Bye. You too.
now.
Leo also got 100 guess on that one. Yeah, Jenny got I got I thought you
Why wouldn't I?
All right, get your homework out. Caleb, Anthony, and Alexis, and who else? You? And Shreya? If you guys are going, it's you have to be arrived at Lyman High School 9:20, 8:20, not 9:20, 8:20. That's about 40 minutes from here. Okay. Are you going, right? You going, right? Going. Okay.
We're getting number one.
It's really hard.
You need to be optimistic. We only get number one. We're gonna get one. I'm like the rock.
Like, do you remember any like one question that's guaranteed like that we could like? Is there like a concept
Do it so like I know that I don't think that's what it is. No, I see your point. Don't reference and go down. I don't know how to do that.
very well?
I did.
No, you didn't do the homework, did you? That's notes. I thought you told me, you texted me, I'm doing my homework. What the hell is this? What the hell is this?
I couldn't tell. You have me until 5 o'clock. Oh, 7 has me until 5 o'clock.
Well, pay attention today.
I was in super.
And then you did it in radio on this side.
Without them yapping about it. And the worst thing is, that right now when you start new habits, the thing is after we're starting to tell you, the thing is after you learn, you don't get more time. I mean, 56 it covers tax. I don't know what I was told they told me I was great. These are the usually they typically cover the like tax. Either way, all I gotta do is get through this. Most of it, and
All right, so some of you guys are still struggling, and I can see that. But one of the things that you have to do is after you did one question, let's just say if you did 2 out of 4. Okay, call it 2 out of 4. I'm not okay with that, but at the same time, I see his point of view. But you rather understand 2 really, really well than understand 4 completely not well. So if you did all 4 things all completely wrong, it's actually worse practice than do 2 correctly. I was watching this this guy who was talking about he was talking about like table tennis training, and he was like he was like number 1 in the world. So he's like you rather like so when you're not focused and you're doing something right without being not focusing without doing something right, that is actually not good for you. You rather like try to do it right, but you still end up to be wrong, but that's fine. But you gotta try to do right. If you accidentally hit a good shot, that doesn't mean anything. But if you start making mistake until you start correcting your shot, then that's better. So what I'm trying to say is you gotta try to fail first. You cannot just give up. Like Arthur, you cannot just give up. I'm telling you. You just look at it. I'd rather you write down something completely off. You can draw me a straight line. I don't honestly give a shit about that straight line. Because at least you have tried to draw that straight line. But if you told me, like, I don't know how to do it, I don't know how to start, I don't know anything, that's bad. So give me something. I think a lot of time I just need you to give me something because I can handle the rest of the part for you. But you gotta take the baby steps. Even we know for sure you're gonna fall. But if you take that, before you fall, I will try to catch you. But if I didn't catch you, fine, you fall on the face. But next time you says, I need to try it a little bit better. But if you don't go through the failure, you're never gonna get better. A lot of you guys don't give a shot at doing something. When it comes down to graphing, especially, I have fear of graph. Larissa, for my 4th period, she hates graph. She will do amplitude period, quarter period, everything. She will not graph for life of God. And I'm like, Larissa, can you just try to fail at something? Try to draw something. If you don't try to draw something, you'll never accomplish anything. You gotta try. If like Nicholas told me, he says, let's go bench 200 pounds. I'm pretty sure I cannot do it.
you can do it.
Yeah, but I will try. And I will fail, and then he had to spot me. If he doesn't stop me, I won't try it.
Same as you.
Okay, so So yes, I'm gonna go ahead and try it. Look at Arthur. Hey, Arthur, I wrestle you, right? Did I know inside my heart that you're gonna beat the shit out of me? Did I know that? Absolutely. You're 50 pounds on top of me, and I still say, sure, let's do it. I have the courage to do that. Do you?
I hear balance.
Luckily, he gently led me on the ground.
Oh, he was really nice.
Yeah, he was really nice. But I'm about to have a stroke that time. When But look, Arthur, I have more balls than you do.
You see that?
Yeah.
Really? Is he really? No way.
He just didn't say it.
Actually, he would say it. What do you
Wait, you're not supposed to.
Right, because that stopped him before.
You're right.
I cannot say that on the